Hello, how's everyone doing? Today's video is gonna be about algebraic linear equations by grouping or bracketing. In terms of bracketing, we will be looking at parentheses, brackets, and braces. Well, this video is gonna be about that. And so linear equations are algebraic equations to the power of 1. Let's start with the first one. We have 30 times x minus, open parentheses, minus x plus 6 plus open parentheses minus 5x plus 4, which it equals minus open parentheses 5x plus 6 plus open parentheses minus 8 plus 3x. So that's a lot already. What do you have to do? Well, apply the distributive property of signs in the first parenthesis, in the second parenthesis, in the third, and in the fourth. When we apply the minus, we know that the positive will then be converted to negative, and the negative will be converted to positive. When we apply the positive, well, the negative stays negative, and the positive stays positive. So, 30x minus minus, which will be positive x, minus 6, since negative times positive means negative, minus, since positive times negative is negative, 5x plus 4, positive times positive is positive, it is equal to negative 5x. Do you know why? Well, negative times positive, and then negative 6, since negative times positive. Alright, in the fourth parenthesis, we'll have negative 8 plus 3x. Now, let's cancel the common terms in both sides of the equivalence. How do we do that? We have in the first side minus 6, so we can cancel it with the second side minus 6. First side minus 5x, second side minus 5x. And let me tell you a rule, a grammatical rule for the algebraic linear equation you may call. If we have minus 2, which is equal to minus 2, then you can cancel. But if you had negative 2 minus 2 in one side of the equivalence, you cannot cancel that. Instead, if you had negative 2 plus 2, then you can cancel it. Why? Well, this one is basically this one, but more condensed in one side of the equivalence, since negative 2 plus 2 is equal to 0, and this as well. Negative 2 is equal to negative 2, and so it is equal to 0 if you pass one to the other side to add. Alright, I think that got clear. So let's continue. So we have 30x plus x plus 4 is equal to negative 8 plus 3x. Perfect. Our next step is to put all the x's in one side and all the numbers, but do they have a variable? They do. Well, the number, like for example here, minus 8, it has a variable applied to it. It would be n times x to the power of 0. That is why the x isn't seen there, but it does have it. So to the numbers that have variables to the power of 0, we shall apply the following. First, let's put the x's on the first side of the equivalence, 30x plus x, and then this x passes to the other side to subtract. Opposite signs. Since it's adding, it passes to subtract. Minus 3x is equal to minus 8, and then this one, you cannot see a variable to it, right? So the variable is to the power of 0. And so 4 passes to the other side to subtract as well, since it's adding. So minus 8 minus 4. Now, what do we have? 30 plus 1, this is technically a 1x. You already have to know that x is equal to 1x. 30 plus 1, 31, minus 3 would be 28x, which is equal to negative 8 minus 4, which would be negative 12. X would be equal, therefore, to negative 12 over 28. Do you know why? The 28, since it's multiplying, passes to the other side to do the opposite, to divide. And so, if we apply the halves to each side, we have 6 and we have 14. Now, what happens? We can continue applying the halves. So, half of 6 would be 3, and half of 14 would be 7. And so x is equal to negative 3 over 7. That would be our first answer for the first example, of course, of algebraic linear equations. It doesn't seem that hard, does it? It's gonna get a little bit more complex later on. For our second example's parent statement, we'll have the following. 15x plus negative 6x plus 5 minus 2 negative, open parenthesis, minus x plus 3 is equal to minus, open parenthesis, 7x plus 23 minus x plus, open parenthesis, 3 minus 2x. And so yeah, it's a lot, but don't worry. What do we have to do? Well, apply the distributive. We have here a positive, here a negative, and a positive, all before the parentheses. And so it would be 15x minus 6x plus 5 minus 2 plus x minus 3. All good for now? Because the minus changes the signs, the positive doesn't. Minus 7x minus 23 minus x plus 3 minus 2x. Alright, that's perfect. Now, what do we have to do? Put the x's on one side, put the numbers with a variable to the power of 0 in the other. 15x minus 6x plus x plus 7x, right here, from negative to positive, plus x. Why? Because negative passes to positive. And lastly, minus 2x, which passes to the other side as a positive. And so that is equal to minus 23 plus 3 minus 5. Where did that 5 come from? Positive 5 passes to the other side as negative 5, negative 2 to the other side as positive 2, and negative 3 to the other side as positive 3. So it would be plus 2 plus 3. Perfect. So now, 15 minus 6 plus 1 plus 7 plus 1 plus 2, that's gonna be 20. And 20 what? Well, 20x, which would be equal to negative 23 plus 3 minus 5 plus 2 plus 3, which would be minus 20. I guess the negative 23 did have a lot to do with that. Alright, so x would be equal to negative 20 over 20. And a number divided by that same number is always gonna be equal to 1. But that 1 has a negative to it, right? So it'd be negative 1. X is equal to negative 1. Now let's go with a third one, which is gonna be the following. 3x plus, and oh geez, here we will have the brackets. What do I mean by that? Well, I mean bracket, negative 7x minus, open parenthesis, 2x plus 7, and close both the parentheses and the bracket, is equal to 12x plus, open parenthesis, negative 14x minus 8. Okay, so first, what do we have to do? Well, we have to first solve for the parentheses and then solve for the bracket. So let's start. 3x plus, that continues to be the same, and now we apply the distributive, right? Minus 2x minus 7, close brackets, is equal to 12x minus 14x minus 8. We apply the distributive property in both sides. Only negatives change the signs, positives doesn't. And if that is the case, then if we have here the positive, it doesn't change, does it? Because we also applied the distributive property to the parentheses, to the brackets, to the braces, to any sort of grouping or bracketing. And so 3x minus 7x minus 2x minus 7 is gonna be equal to 12x minus 14x minus 8. So we need to have common terms in one side of equivalence, right? So 3x minus 7x minus 2x, 12x passes to the other side as negative 12x, and negative 14x passes to the other side as 14x. So now that is equal to negative 8. But what happens? Well, we have here a negative 7, and that passes to the other side as a positive 7. Alright, 3 minus 7 minus 2 minus 12 plus 14, that would be minus 4. And with what variable? X. That would be equal to minus 1. Alright, so x is equal to negative 1 over negative 4, which we cancel out the signs, and so x would be equal as 1 over 4. Perfect, that would be it. Now what happens? How shall we possibly verify it? Because that is crucial. When you want to correct yourself while doing a linear equation, you just have to know the value that x is equal to, and then substitute that with each one of the variables in the equation. So for example, 3 times x would be 3 times 1 over 4. Negative 7 times x would be negative 7 times 1 over 4. And what happens? Well, the following happens. The number you get on the first side of the equivalence has to be equal to the number you get on the other side of the equivalence. If it isn't the case, then you know that the value is wrong, or you did it on the calculator wrong. That is basically how you check if you got it correct. So now let's pass to the fourth example, when we have the parent statement of 18x minus bracket 5x minus parenthesis 8 minus 4x and closing bracket is equal to 32x plus bracket minus parenthesis 2x plus 7 minus parenthesis 4x plus 8. And then we close the brackets. What do we have to do first? First, we will solve the parentheses. Great. Now next, we will solve the brackets. And lastly, we put the common terms on one side, for example the x's on one side, and the numbers in the others. Let's start. 18x, you know what comes next. Now negative times positive, negative x, negative negative, positive 4x would be equal to 32x plus bracket negative 2x, negative 7 minus 4x minus 8. And then you close the bracket. Now, what do we do? Well, we solve the brackets, right? 18x minus 5x plus 8 minus 4x. Remember, negatives and positives. When do we change? It's equal to 32x minus 2x minus 7 minus 4x and minus 8. Alright, so we have now solved the brackets. Then common terms on one side, common terms on the other. I mean, variables on one and constants on the other. 18x minus 5x minus 4x minus 32x plus 2x plus 4x. You keep this same sign if you don't change the side of the equality. But if you change sides, well, you must change the signs here, here, and here. Now, what about the constants? Well, which ones are gonna remain? Negative 7 and minus 8, right? Those two. This one and this one are gonna remain. But which ones are gonna pass to the other side? The 8 will pass to the other side to be a negative 8. Perfect. The one side will give us minus 17x and the other side will give us minus 23. And so x is equal to minus 23 over minus 17. We cancel both of the signs and we get x is equal to 23 over 17. You cannot simplify that since there's nothing common between those two. Those two don't have a common divisor between them. Alright, so now let's go to the fifth example. The fifth example about what? Alright. Parent statement is 85 plus open bracket minus 6x plus open parenthesis minus 8 plus 4 and then close both parentheses and bracket is equal to 27 minus open bracket minus open parenthesis 2x plus 7 minus open another parenthesis and there 8x plus 5 and then close. So now, what do? We start with the parentheses, right? The parentheses are these ones, not this square, but the round ones. 85 plus the bracket minus 6x minus 8 plus 4. It doesn't change anything since it is distributed by a positive sign. Is equal to 27 minus open bracket minus 2x minus 7. Here we change the signs and here we will change the signs as well. Minus 8x minus 5. Alright, so now we start solving the brackets, right? So 85 minus 6x minus 8 plus 4 would be equal to 27 plus 2x plus 7 plus 8x and plus 5. You see that the whole bracket before was entirely negative, right? But now, since we applied another negative, it becomes entirely positive. What do? Well, you know the drill. It's only common terms on one side and common terms on the other. Minus 6x, and then we don't have anything else, so we must switch sides. Plus 2x becomes minus 2x, 8x becomes minus 8x. So that is equal to 27 plus 7 plus 5 and then the common terms on the other side. 85, 8 and 4. Minus 85 plus 8 and minus 4. Is that clear? I hope it is. So the first side of the equivalence will give us minus 16x. The other side will give us minus 42. And so x would be equal to minus 42 over minus 16. Right? The 16 was multiplying, it passes to the other side to divide. It's as simple as that. We cancel the signs, we now apply the halves. So what is the half of 42? It is 21. What is the half of 16? It is 8. And so x is equal to 21 over 8. That would be our solution for our fifth example. And even if you think these ones are difficult, then the next one will be the double. Why? Because we have already seen parentheses, we have seen brackets, but we haven't seen braces. The parentheses are inside the brackets, and the brackets are inside the braces. Simple? Now that we have covered that, first of all, let's erase because this example will be really long. And I hope it's not long enough that it won't fit in the board. So, minus, open brace, 3x plus 8 minus open bracket, minus 15 plus 6x minus open parenthesis, minus 3x plus 2 close parenthesis, minus open parenthesis 5x plus 4 close parenthesis, close bracket, minus 29, close brace, and that would be equal to minus 5. Alright, that wasn't that complicated. Well, it kinda is, but not that much. What do we have to do first? We have to solve the parentheses, first of all, and then after that, well, we solve the brackets. After solving the brackets, we start to solve the braces. That's the natural order, right? So, let's start doing it. You guys already know the distributive property of the signs, right? If you do, then do it, and then let's check. Negative, you know what comes next, right? So, we are already hitting up our first parenthesis. What do? Negative times negative is positive 3x, and then negative 2. Now the second parenthesis, minus 5x minus 4. We have already done the parentheses. Now let's start with the brackets. We have already seen that there is a minus, so we have to change every single sign inside that bracket. So let's start. And so it would be plus 15 minus 6x minus 3x plus 2 plus 5x plus 4 minus 29. And then we're just left with the braces. But would you look at that? The braces also have a negative to it. And if they have a negative to it, well, we're kind of screwed because we have to change every single sign of the terms inside the brace. So, minus 3x minus 8 minus 15 plus 6x plus 3x minus 2 minus 5x minus 4 plus 29. And so that would be equal to minus 5. Now we have to rearrange. That's the sad part, because of course we have all our terms in the first side, but none in the second. So remember, variables on one, constants on the other. Minus 3x plus 6x plus 3x minus 5x would be equal, and here I would take the opportunity to start canceling out terms with opposite signs. So minus 3x and plus 3x. That would be equal to minus 5, and then we start taking terms from one side and passing it to the other. Plus 8 plus 15 plus 2 plus 4 and minus 29. Good? Alright. This would be x, and what would be the second side? Minus 5 plus 8 plus 15 plus 2 plus 4 minus 29. It would give us a value of minus 5. Now let's start with 7 that you, on your own, I'm talking to you, you on your own will do. Of course, I'm gonna help you. So for 7 example, we have 4x plus 2x minus 3 as equal to 5x minus open parenthesis 8 minus 2x. And so, how would you solve it? First of all, distributive property. 4x plus 2x minus 3, and that is equal to 5x minus 8 plus 2x. Then common terms. So 4x plus 2x. The 5x of the other side passes to subtract. The 2x, the same story, minus 2x, and so it will be equal to minus 8, and then the minus 3 from the other side passes to add. So minus 8 plus 3. All good? Now we cancel out common terms with opposite sign. Plus 2x minus 2x. Simple. 4 minus 5 would be minus 1, of course, and if it's a variable, then minus 1x would be equal to minus 8 plus 3 would be minus 5. And so what happens if we have negative signs on both sides? Well, we can multiply by negative 1 in both sides to get x is equal to 5. How do you check it, you may ask? You grab the 5 and you put it in all of the variables. Which ones are the variables? Well, the x. The x's are the variables, so you slap the 5 on it, and then you do the whole operation, making sure that this side must be equal to this other side. Good? Now let's pass to the 8th and almost last example, because we will have 9 examples. What is our parent statement? 10 minus, open parenthesis, 3x plus 2 is equal to 2 times, open parenthesis, 4x minus 5, close parenthesis, plus, open parenthesis, x minus 1. And so we apply the distributive both in signs and of terms. What do I mean? Alright, 10 minus 3x minus 2. Guess you guys already did that. Would be equal to 2 times 4x would be 8x. 2 times negative 5 would be minus 10. And then you have the whole other fraction that you must apply the distributive property of the sign. So, plus x minus 1. Simple. Now, common terms. Remember, we have minus 3x, and then we pass the 8x as well as the x. It would be minus 8x minus x equal to minus 10 minus 1, and then we pass the 10 to the other side and the 2 to the other side. The 10 would be with a negative sign and the 2 would be with a positive sign. And so the first side of the inequality would be minus 12x. What about the second? The second would be minus 19. And so x is equal to minus 19 over minus 12. We cancel the signs and then x is equal to 19 over 12. There you have it, and that is the answer for the 8th question. Now what about the 9th and last? This exercise is not that hard, but I want you to first do it. Alright, so pause the video when I finish the parent statement, and then you guys can consciously do it yourselves. Do it first and then you check my review. Alright, so now let's start with the review. We must clarify that here we apply the distributive property of both signs and terms. So the terms is in the first parenthesis. 2 times 5x would be 10x. 2 times 1 would be plus 2. That is added to 3 and then minus x plus 2, right? Because of the distributive property of signs. Then that is equal to 4x minus 7 plus x. Why? Because of the same thing. Distributive property of signs. Perfect. Now, the x's on one side, the constants on the other. 10x minus x minus 4x minus x. Why? Because the 4x and the x passes to the other side to subtract. That would be equal to minus 7 minus 2 minus 3 and minus 2. Correct? All of these have positive signs and thus they pass to the other side to subtract. In the first side of the equivalence we will have 4x. In the second we will have minus 14. And so x is equal to minus 14 over 4. When we get the halves, we will obtain 7 and 2. X is equal to minus 7 over 2. Alright, thank you all for watching. After having solved 9 different examples of the linear equations by grouping or by bracketing, did you all finally understand what parentheses, what brackets, and what braces meant? I hope you did. I hope you did understand as well the distributive property of both signs and terms. That would be it. So I hope you guys loved this video, learned a lot from it, and I'll see you in the next one. So